All right. I told us we'll look at an example of a Sylvester's matrix. So you want to get everything we are doing and ensure you follow the playlist. Sylvester's matrix theorem. This is an example. This is a matrix. A is equal to 3 minus 2, 1, 0. What is the first steps you take to be able to solve this? Step 1, find the eigenvalues. Right? A minus lambda 1. This is what you have. 3 minus lambda minus lambda. I have minus 2, 1. I'm sure you all understand that. So look for the determinant. I told you that when I was teaching the types of matrices, I told you how to look for the determinant. I taught you how to look for the determinant. So what do? Multiply this and this minus, multiply this by this. This is what you have. When you break it this way, come all the way to this place. We all know factorization. So your lambda 1 is 1. Lambda 2 is equals to 2. Step 2, find the column eigenvectors. Right? We find the column eigenvectors. And then we also still go back to finding the row eigenvectors. Now we have lambda 1. So for lambda 1 is equals to 1, what do you have? You have a minus 1 bracket x equals to is 0. Right? So this is minus 1. The same minus 1, see the way you apply lambda here, you also apply it here. When we say lambda, now we have the value of lambda. Just put the value of lambda there, right? You have 2 minus 2, 1 minus 1, right? It's a non-zero vector. So you have x is equals to xy, right? So what do? This is very simple. You all understand that. Multiply all this by x and y, right? I think I taught you product matrix. And if you have not done the product matrix, please go through it, right? Then at the end, you have this. Are you getting the point now? X times 2, 2x. Y times minus 2, minus 2y. Is that okay? You go over again. X times 1, I have x. Y times minus 1, you have this. All is equal to 0. So from there, what happens? It gives you x is equal to x, or y is equal to x, which is the same thing. So you choose x is equal to 1. So in other words, we have our c as 1, 1, since x and y are the same. Is that okay? For lambda 2 is already 2, right? And then we have a minus 2, 1 times 1, x is equal to 0. So you do the same thing. Remove minus 2, since we have lambda as 2 equals to 2. Remove it from this equation. We have what we have here. Is that okay? I think that is clear. So follow the same pattern that you saw there. Is that okay? Multiply 1 by 1 as usual. You eventually you arrive at this x is equals to 2y. Right? So your C2 will be 2, 2, 1. I think that's clear. In step 3, we'll find row eigenvector. I told us that. Right? And it satisfies RA is equal to lambda R. For lambda 1 is equals to 1. We would have continued so that we'll be able to solve that. I think you understand what I'm talking about. So it's just like making R resorted to the formula. Is that okay? And then you have your lambda 1 already. So for lambda 1, what do? You put it here now. Then when you cross whatever you need to do, you still arrive at this value. Right? We may not be going into all those elementary stuff. So, but don't worry, the step 3, I'll still make it clearer when we take it again. I hope you understand this now. So far, I've been able to explain with respect to the Sylvester's matrix theorem. We are not done yet, but the next video, like I told you, follow the playlist, right? One after the other. You'll be able to get all that we are explaining. And if you have any question, put it on the comment section. Thank you.